Hi everyone. I'm going to ask you a question, and apparently I'll show you a failure of Newton's third law. Right? A very simple example, um, and you have to think through and figure out where exactly is the flaw in my logic. But before I do that, I need to give you some background information, which some of you may already have. So you need to understand the concept of friction. So let's say there is a surface. It could be a floor, could be any flat surface. Let's say you keep a box, or say, let's say there is some object here, right? So what happens? The surface will push it up. So there'll be a force on this box in upward direction, right? And this force we call it the normal force. But in addition to that, there is also let's say if somebody tries to push the box in this direction, right? If I try to push the box, let's say in this direction, then there will be, if the surface is not smooth, if it is a rough surface, there will be a force in this direction as well, right? And this force is called the friction force. This force is called friction force, right? So there is a normal force, and if the surface is not smooth, and if they try to move against each other, then there will be a friction force. If I show them separately, right? So there is a normal force and there is a friction force. And what will be the total force? The total force would be a vector sum of these two. So if I use the parallelogram law, right? So this is going to be the total force F acting on this object. But the key thing is, for the friction force to act, the surface has to be rough. It cannot be a frictionless surface. Now here is a paradox. So let's say there is this guy, okay, and this guy is walking, right, and he puts the front foot forward. This is a front foot, right? He puts the front foot forward at a certain angle, right, and this is the floor, right? Now the key thing is, the floor is frictionless. Okay. So now what happens? Now you have to hear this argument very carefully, right? So I'm just saying that in this guy, he's putting his feet at a certain angle. It's not vertically, he's putting at a certain angle. So he's applying a force, let's say in this direction, right? And this force is, let us say, I'm going to call it F1 vector, right? Now the floor is frictionless, so it cannot have a horizontal component. The floor can only apply a force upward. So the floor is applying a force on the man in upward direction, right? Let's call this F2, right? So the man is applying a force in this direction at a certain angle, and this F1, and the floor is applying a force on this F2. If I show it separately, so let's say the force on floor, right, shown in red, this is at a certain angle, and the force on the foot of the man, shown in white color, it is upwards, right? And so this is F1 and this is F2, let us say, right? And Newton's third law says that action-reaction forces, they're equal and opposite. So Newton's third law says that F2 should be equal to minus F1. What third law says? Here this is not true. So this is false, right? You can see they're not opposite. So I'm making a claim that third law has failed. Third law has failed. Is there a problem in the argument I have made, or is the third law, did we, like, in 2018 we found a flaw in that argument, right? So you have to think about it and then give me the answer, and I will discuss the solution separately. Thank you.